Hi everyone. As you can tell, I'm not here, but that doesn't mean we're not going to star review. So today we're going to talk about geometry. So we're going to talk about area and circles and polygons and composite figures, and then angles. So we'll go through it pretty quickly, and then remember after the video, make sure you get to your quick checks, and then the last day that I'm going to accept them is going to be Friday, April 26th. So 1 week from today. All right. First, let's talk about polygons. So the first thing that we're going to talk about is triangles. So the way that you find the area for a triangle is that's area equals 1/2 base times height, or area equals base times height divided by 2. The reason that you can use either one is because multiplying by 1/2 and dividing by 2 are the same exact thing. They will give you the exact same result. So let's take a look at these triangles real quick. Each of these triangles has a base. And they also have a height. Now, one thing that is not on your cheat sheet, but that I would like you to write, is that the height makes a 90-degree angle with the base. Now, box that in, star it, do whatever you need to bring attention to it, because what they are going to try to do is they're going to try and trick you. So, for example, they might give you a triangle that looks like this, where the base is, let's say, 20. The dotted line is 15. And this slant line, let's say, is 20 as well. Well, if you know that the height makes a 90-degree angle with the base, then you will know that this 20 is extra information. So it's really important that you know that the height makes a 90-degree angle with the base. And the way that you can tell if something is 90 degrees is they put that little square. Okay, so that's what you need to be looking out for. All right, now let's move on to quadrilaterals. Quadrilaterals have 4 sides, hence the name quadrilaterals. First, we have a rectangle. So we have the area equals base times height. Next, we have a parallelogram. Also, area equals base times height. Now you're like, why do these two things have the same formula? Well, if you remember from when we did this unit, if you were to cut down this dotted line and move this triangle from this side of the parallelogram to this side of the parallelogram, you'll see that it makes a rectangle. Therefore, they have the same formulas. So these also have bases and heights. And the same rule applies. They also make a 90-degree angle with the base. Now we get to our trapezoid. Now the trapezoid has a bit of a different formula. So we have area equals 1/2 base 1 plus base 2 times the height. Now, because we're adding base 1 and base 2 together, it does not matter which one you use for base 1 and which one you use for base 2. For example, 9 plus 5 is the same as 5 plus 9. So when you're adding, it does not make a difference. All right, now let's move on to circles. So the first thing that we're going to do is we're going to name parts of the circle. So from the middle point of the circle to one edge, that is called the radius. So from the middle of the circle to the edge is called the radius. A line that goes from one edge of the circle all the way through the middle to the other side is called the diameter. It has to go through the middle. If the line does not go through the middle, then it is not the diameter. And then last but not least, all the way around the circle, essentially it's the perimeter of the circle, that is called the circumference. So all the way around is the circumference. Now the way that you find the circumference is with the formula circumference equals pi times diameter. Pi times diameter. And you find the area by multiplying pi times r squared. Now remember, it's not the radius times 2, it's the radius times the radius. A couple of things that I want you to make note of is that if the radius equals 5, then the diameter equals 10. So the radius is half of the diameter. So the radius is half the diameter, which we can clearly see with our diagram. All right, so the area of a semicircle can be found by dividing the area of the whole circle by 2. So semicircle is just half of a full circle. Now the number that you're going to use for pi is 3.14 or 3 and 1400ths. Or you're going to use the fraction version, which is 22 over 7. All right, let's move on to composite figures. These might look difficult, but I'm telling you they're not. So a composite figure is a figure that can be decomposed. It can be decomposed into basic shapes. And you all know how to find the area of a triangle. You all know how to find the area of a rectangle or a parallelogram or a trapezoid or a circle. So what these figures are, it's 2 or more shapes that are put together. And so in order to solve these, all you have to do is take them apart. So for example, this first one here looks like an arrow, but you can clearly see that it's not just an arrow. It can be decomposed into a rectangle and a triangle. So if you wanted to find the area of this figure, you would find the area of the rectangle, and then you would find the area of the triangle, and then you would add them together. Next, we have what looks to be a parallelogram that's shaded, and an unshaded circle. Now, the majority of the time when you see a figure that is shaded, they're asking you what is the area of the shaded region. So in this particular problem, you would find the area of the parallelogram, then you would find the area of the circle, and then you would subtract the 2 because you only want the shaded region. And then our last example of this, it kind of looks like a track, but we can clearly see that it is a rectangle and 2 semicircles. And we know that a semicircle is just half of a circle, which means 2 semicircles make a whole circle. You're going to find the area of the various shapes, and then you're going to add or subtract based on what the question is asking. So like these 2 examples that we talked about, here it's probably going to be like, all right, so what is the area of this composite figure? Where you would find the area of the rectangle, find the area of the triangle, and then add them together. Whereas this one, they're probably going to say something like, take this composite figure and what is the area of the shaded region? So in this case, you would have to subtract. Lastly, let's talk about angle relationships. So the 3 angles in a triangle have a sum of 180 degrees. So what that means is if you were to take all 3 angles and add them together, you would get 180 degrees. Now, for example, in this example, we don't know one of the angle measures. So what we can do is step number 1, we can add together our known values. In step number 2, we can subtract it from 180. So step number 1 would be 75 plus 33. Those are my known angle measures. 5 plus 3 is 8. 7 plus 3 is 10. Step number 2 is I subtract from 180. So I borrow. This becomes a 10. 10 minus 8 is 2. 7 minus 0 is 7. So x equals 72 degrees. Last but not least, we're going to talk about complementary angles and supplementary angles. Complementary angles add up. So they add up to 90 degrees. And supplementary angles add up to 180 degrees. Now, when I was your age, the way that my teacher taught this was to look at the letter P in each of the words to help me remember which one would add up to 90 and which one would add up to 180. So if you look at complementary, there is only one letter P, whereas supplementary has 2. We all know that 2 is greater than 1. So supplementary is going to add up to 180 and complementary is going to add up to 90. So let's look at our diagram here and let's pick out angles that reflect complementary and then supplementary. So one example of 2 angles that make up 90 degrees would be angle DBE. So if I were to take my pen or pencil or whatever you have, and I start at D, I go down to B, and then I go up to E. So exactly what we wrote down. And angle EBF. So if I do the same thing, EBF, if I were to combine those 2, I'm going to get 90 degrees. And it's really simple if you just follow the letters. So I start at D, B, and then E. And then my second one would be E, B, and F. And we know that that is 90 degrees because it has that little square right there. Now let's talk about supplementary angles. So supplementary add up to 180. So our example of that would be angle ABC and angle CBF. So I'm going to do the same exact thing. So I'm going to start at A, A, B, and then go up to C, and then C, B, F. So if I combine these two angles, it's a straight line, which means that is 180 degrees. All right, if you have any questions, send me an email and I will do my best to get back to you. Or if you want to ask Mr. Solis, he might just be able to help you. I'm pretty sure he'll be able to, especially with your cheat sheet and having all of your notes on there. Remember, your quick check is due on Monday at 1 o'clock. So when you come into class on Monday, it's due. And then all of them are going to be due on Friday the 26th. I will not accept any after that. Remember, they are being averaged for a test grade, and you want to do them so that you can be better prepared for your STAR test that is on Wednesday of next week. Y'all have a wonderful weekend, and I'll see you on Monday.